not in the subspace of vector space. Everything we have discussed in that video along with the few problems. Yeah, so in this video we are going to discuss with linear combination. Okay, what is linear combination? Let us see it now. Let V be a vector space over a field F and let V1, V2, V3 up to Vn belong to this vector space V. Okay, now any vector of the form a1 v1 plus a2 v2 plus a3 v3 up to an vn, where a1 a2 an are some constant values in the vector space V, where ai, that is a, all the values of a1 a2 a3 up to an comes under ai, belongs to F, then it is called the linear combination of the vector space V. Okay, so linear combination means if we have a vector space where v1 v1 values are from v1, v values are from v1, v2, v3 up to vn, it belongs to V, then its coefficients or the constants from a1 to an along with this vn, these all belong to the belongs to the set of F vector. So then we can say that it is a linear combination of this vector space. Okay, yeah. Next, let us see about linear dependence. Let V be a vector space over the field F. The vectors v1, v2 up to vn are said to be linearly dependent over F if the scalars, that is a1, a2 up to an, belong to F and their linear combination is equal to 0. Okay, if you do its linear combination, that is by adding a1 v1 plus a2 v2 up to an vn, if we get our answer as 0, then we can say that it is linearly dependent. Okay, but if ai is not equal to 0, that is for all the values of ai not equal to 0 where I belong to n, the values of a1, a2 and an, it should not be equal to 0, it should be a set of natural number itself. Okay, it should not be equal to 0, then only the linear dependent condition satisfies. Okay, if we get this part, if we do the linear combination part and if we get our answer as 0, then we can say that it is linearly dependent. Similarly, for linear independence, let V be the vector space over a field F. The vectors v1, v2 up to vn are said to be linearly independent over F if scalars a1, a2 up to an belong to F, so that a1 v1 plus a2 v2 up to an vn is equal to 0. But here in this case, ai should be equal to 0. That is, these values should be equal to 0. Then only we can say that it is linearly independent. Okay, if ai equal to 0, then it is independent. Okay, if any of the values of a1, a2 up to an is equal to 0 at some stage of time, then we can say that it is linearly independent. Okay, yeah. Where I here belongs to the set of natural number. So this is the next question, 4a. Here they have given, are the vectors 2, 5, 3, 1, 1, 1 and 4, 2, 0 linearly independent or not? Okay, we should be justifying whether this is linearly independent or linearly dependent. First, for that you should be knowing the condition for linear dependence or independence. That is, I have already told you under model paper 1 solution 1 condition, that is we should be considering xv1 plus yv2 plus zv3 equal to 0, where v1, v2, v3 are the three vectors mentioned here and x, y, z are the vector coefficients, that is here in this case, since there are three vector coefficients x, y and z. Okay, that would be equal to, we should be equating it to 0. Now substitute the values of v1, v2, v3 here, then multiply x, y and z to these vector coefficients, that is it would be 2x, 5x, 3x, y, 4z minus 2z and 0z. So now the first equations, you should be writing the equations which consists of all the three variables x, y, z. So all the first components you write it first. 2x plus y plus 4z equal to 0, 5x plus y minus 2z equal to 0, 3x plus y plus 0z equal to 0. So where these terms on in the right hand side of these equations are the number of unknowns. So in this case there are three number of unknowns. So now put a into x equal to 0, where a is the coefficient matrix of this equation, that is 2, 1, 4, 5, 1 minus 2, 3, 1, 0. Okay, so now you should be doing the calculation to find the rank of the matrix. So here in this case you should be doing these two elements equal to 0, right? So the first row as it is, the second row would be replaced by 5r1, 5 times the opposite row minus 2 times the second row. Okay, the opposite rows would be getting multiplied to the opposite coefficients of the rows. So here R2 would be replaced by 5R1 minus 2R2, and R3 would be replaced by 3R1 minus 2R3. Okay, so do the necessary replacements so that these first two elements would be equal to 0. So now here this term would be replaced now by 3. Why? Because 5R1 minus 2R2. 5 times R1, that is 5, minus 2 times R2, that is 2. 5 minus 2 is equal to 3. Now 5R1, that is 2 into minus 2 into 5, that is minus 10, minus 5R1, so 4, right? So 5 4s are 20, then minus 2 into minus 2, that is minus 4. So 20 minus 20 plus 4 is 24. Minus 2 into minus 2 is plus 4. So 20 plus 4 is 24. So here it is 1, because 3R1 minus 2R3, it is again 1, because since these two are 1 only, so 3 minus 2 would be equal to 1, and this would be 0 as it is. Okay, so now under echelon condition we should be doing the this term now. This term should be equal to 0. So replace with R3 with respect to keeping R2 row. So that way R3 would be equal to 3R3 minus R2. Since these are the two elements here, 3R3 minus R2, just replace the elemental configuration under different element rows. Okay, so R3 would be replaced by 3R3 minus R2, so that this term would be 0, and this is the A matrix. Here you see here rank of matrix is 2. Why? Because we have one number of 0 rows, okay, where all the elements are 0, so this is not considered, only these two rows are considered. So that's why rank of matrix is 2, and number of unknowns here in this case it is 3. So in this condition rank of matrix is not equal to number of unknowns, that is 2 is less than 3. Since 2 is less than 3, since one unknown is constant, that is one unknown is not equal to 0, because in the independence condition we have already seen that we have all the variables x, y, z are equal to 0, but in this case any one variable is a non-zero element. So that's why we could be saying that the vectors are not independent in this case, either they are linearly dependent. Okay, so if they are not independent, the other option left is that they should be dependent. So yeah, so in this case they are not independent. In order to justify, you should be writing that they are not independent, since one unknown is constant and rank of matrix is not equal to the number of unknowns. So they could be saying that the vectors are linearly dependent to each other. Okay, so this was the problem, guys. Note it down, 4A. That problems I'm going to solve it now. So this is the first question, rank nullity problems. Verify, very important. Okay, mark it as important. Okay, sure question for 8 marks. Verify rank nullity theorem for the transformation given as t tending from r cube to r cube, defined by t of x comma y comma z is equal to x plus 2y minus z comma y plus z comma x plus 2y x plus y minus 2z. Okay, so this is the given condition, and we should have told us to verify the rank nullity theorem. Okay, first step while solving this problem is we should be finding the basis of nullity of t. To find basis of nullity of t, first you should be taking let v equal to x comma y comma z belong to r cube initially. Okay, such that, observe carefully what I am writing here, nullity of t is equal to v belonging to the vector space v, where t of v would be equal to 0. Okay, so therefore we can say that t of v is 0, so t of x comma y comma z also is equal to 0, right, according to this what we have written. So what is t of x comma y comma z? X plus 2y minus z comma y plus z comma x plus y minus 2z is equal to 0. We are having 3 terms, so add 3 zeros as well here also. Okay, so from this what we would be getting, 3 equations you would be getting, that is x plus y minus 2z equal to 0, y plus z equal to 0, and x plus y minus 2z equal to 0. Okay, we got these three equations. We should be solving these three equations and checking for the values of x, y and z. Okay, let us see what we would be getting. On solving, first let us write the smaller equation, that is y plus z equal to 0. So we would be getting y is equal to minus z. Okay, this is one term. Since we got y equal to minus z, so what I am doing is, other two equations are there, right? In that other two equations, the value of x and z I am writing in terms of z only. Okay, that is, now consider this term x plus 2y minus z equal to 0. Here substitute the value of y as minus z. So x plus 2 into minus z equal to 0. So x minus 2z minus z equal to 0. X minus 3z equal to 0. So x would be equal to 3z. Okay. And also this final equation, x plus y minus 2z equal to 0. So substitute the value of x as 3z, y as minus z, and 2z you keep it as it is. So we would be getting 3z minus z minus 2z equal to 0. So 3z minus 3z equal to 0, or 3z equal to 3z. So we would be getting z equal to z. Okay, so we got all the values of x, y, z in terms of z only. After that, therefore, write x comma y comma z is equal to whatever answer we got, that is 3z minus z, z, or we can say z, take it common, 3 comma minus 1 comma 1. Okay, so this is the basis of nullity of T. Therefore we can conclude by saying that nullity of T, since nullity of T is the dimension of kernel of T, then we can say that nullity of T is equal to 1. Okay, since we have only one set here, so that's why we could be saying that nullity of T equal to 1. Okay, so in this way you should be solving for nullity of T. So now similarly you should be solving for rank. Okay, how to solve for rank, let us see it now. Okay, now next step is to find basis of range of T. Okay, as 1 0 0 0 1 0 and 0 0 1 belongs to R cube. Okay, it's the basis of R cube. Okay, so therefore we can write it as T of 1 0 0 comma T of 0 1 0 comma T of 0 0 1 belongs to range of T. Okay, this is the range of T. Just add T to this R cube. So we can write it as T of 1 0 0. Solve it separately. That is, they have given the value, right? In the question they have given the set of x, y, z, that is x plus 2y minus z, right? So here x is 1 plus 2y, that is 2 into 0 minus 0, comma y plus z, that is 0 plus 0, comma x plus y minus 2z, that is 1 plus 0 minus 2 into 0, that is 0 itself. So we would be getting our answer as 1 0 1. Similarly for T of 0 1 0, again x plus 2y minus z, so 0 plus 2 into 1 minus 0, comma y plus z, that is 1 plus 0, and x plus y, that is 0 plus 1 minus 2z, okay, that is 2 into 0, that is 0 itself. So here we will be getting 2, 1, 1. Similarly, finally 0, 0, 1. So again x plus 2y minus z, 0 plus 2 into 0 is 0, minus 1. Then we have y plus z, that is 0 plus 1, and x plus y minus 2z, 0 plus 0 minus 2 into 1, that is minus 2. So we will be getting our answer as minus 1, 1, minus 2. Okay, so therefore we can say that the range of t is 101, comma 211, comma minus 1, 1, 2. Okay, so this is the range of t. Okay, now next step is to find the basis of range of t. We should be considering a matrix. Consider a matrix that is A. Consider a matrix A where the coefficients are whatever we've got here, the range of t, that is 101, 211, minus 11, minus 2. Okay. Now again, to find the rank, you know the procedure, right? To find the rank, just do the second and third column, third row, first two elements as 0. So R2 with respect to first row R1 would be R2 minus 2R1, and R3 would be equal to R3. Already minus 1 minus sign we have, this would be plus R1. Okay. So do that change and write the matrix here. I'll write it here. First row as it is 1 0 1. These two elements should be 0. And here now R2 minus 2R1. 1 minus 2 into 0, that is 1 itself. So 1 minus 2 into 1, that is 2. So 1 minus 2 is minus 1. So here R3 plus R1. 1 plus 0 is 1. Minus 2 plus 1 is minus 1. Okay. Now this term you should be making it 0. So R3 with respect to R2 you should be changing, that is R3 minus R2. So if you do 1 minus 1 you will be getting 0, right? So R3 minus R2. So write the changed matrix 1 0 1 0 1 minus 1 0 0 R3 minus R2, that is minus 1 minus of minus 1, that is minus 1 plus 1. Again we get 0. Okay. So from this what we get? Rank of t. Okay, now consider t because we get 1 0 1. Consider the non-zero rows 1 0 1 and 0 1 minus 1 form a basis of range of t. Okay. These two, consider non-zero form, they would be forming a basis of range of t. So we have one more relation, that is dimension of range of t equal to 2, and also dimension of range of t is equal to rank of t. So rank of t would be equal to 2 finally. Okay. So therefore rank of t is 2. Now finally, in order to verify for rank nullity theorem, dimension, they have mentioned it in the question, r cube, right? So we should be getting 3 in order to rank nullity theorem to be verified. So rank of t is 2 and nullity of t we got it as 1 set. So 2 plus 1 is equal to 3. So dimension of vector space is r cube. So it matches here. So we can say that rank nullity theorem satisfied. Okay, so this is the complete problem, guys. Hope it is clear. Please go through each and every step very carefully to find the basis of range of t, rank of t, also the nullity of t. So please do solve it, guys, and try to understand, because this is very important. One question would be definitely asked. Okay.